Okay, let's see if you practice questions on periodic classification, periodic properties. So I'll read the question, give a pause, you'll pause the video and try to think about the answer on your own. If not, you can play the video to see the answer immediately. So you have to pause it after every question so that you can take time to think about the answer. Okay, the first question is, which of the following set contains pair of elements that do not belong to the same group but show chemical resemblance? So it's asking which elements have similar chemical properties. Out of the options, beryllium and aluminium show similar properties because they are diagonally related to each other. That is called as diagonal relationship. In the periodic table, these elements show diagonal relationship. That is, they are present diagonal to each other and have similar properties. That is due to similar polarizing power, which is ionic charge by ionic radius square. Don't think that will proceed to the subsequent elements. No, it is restricted to these pairs. That is called as diagonal relationship. So the next question is, the screening effect of d electron is, you can have look at the options: equal to p electron, much more than p electron, same electron, less than p electron. Okay, the answer for this is, the screening effect of d electron is less than that of a p electron, because the d electron is more dispersed in shape, whereas a p electron is less dispersed. So more is the dispersion, less is the screening effect. Similarly, an f orbital screens even poorly, whereas an s orbital screens better. That is because of their shape. So that is the order of screening effect also. Let's proceed ahead to the next question. The size of the isoelectronic species F minus, Ne and Na plus is affected by. So you have the options: nuclear charge, principal quantum number, electron-electron interactions in the outer orbital, none of the above. So let's go by the options in this question. Nuclear charge, it would have been better if it is effective nuclear charge. So I'm not choosing that. Principal quantum number is N. It doesn't affect anything related to size unless until a new shell has been added. Here all of them are present in the same shell. So it is definitely decided based on the interactions in the electron that is present in the outer orbital. So the answer would be C. The next question is, in a given energy level, the order of penetration of different orbitals is. So as you can see, the options, there are different orbitals and the order of penetration effect is asked. The penetration power of an orbital, we can call it as the ability to attract an electron in an orbital, and also we can say if the penetration power is more energy is released when the electron is attracted into that orbital. We know out of all the orbitals, an s orbital has greater penetration power. That is also the reason why s orbital has greater electronegativity. So penetration power is decided by the amount of closeness to which the electron can reach towards the nucleus. So the order of penetration power is greatest for S, followed by P, D and F. So the right answer would be A. Moving ahead to the next question, which of the following van der Waals radius is the largest? So this is a tricky question. The options are neon, chlorine, oxygen and fluorine. So in general we know noble gas elements have larger van der Waals radius because they are non-bonded. We might think like that, but here you should also consider the period in which they are placed. Chlorine is placed in the period below neon, oxygen and fluorine. So obviously the size is highest, so there is undoubtedly chlorine will be the answer. Which of the following electronic configuration represents most electropositive element? In general, we know electropositivity. What happens? Electropositivity is a tendency to give the shared pair of electrons. So electropositivity will definitely increase with size. You know, ionization energy decreases with size. Thereby, ionization energy is the amount of energy required to remove an electron. So you should be able to remove the electron easily. So that means there is a tendency to give the electron, that is electropositivity. So larger the size, greater will be the electropositivity. So down the group we know size increases. So it should be present below in the group. And if we see from left to right, in the left we have metals, in the right we have non-metals. Metals have tendency to give the electron, non-metals have tendency to lose the electron. So the element should be present towards the left and down in the group. So if we see the first group, as we go down the group, we have cesium. Exclude francium because it is radioactive. So cesium is the most electropositive element. So in that way we have to see the configuration of cesium, which is nothing but xenon followed by 6s1. So it would be cesium. It cannot be 6s2 because it is paired. It would require more ionization energy to unpair, or electropositivity is less. That's it. We'll add up more questions later.